All right, let's talk about algebra. I know, for some people, that word can sound a little intense, but I want you to think of it a different way. At its heart, algebra is just a puzzle, a kind of logic game. And today, we're going to learn the rules and solve it together.
So, let's start with a question. You might be looking at these blocks and thinking, okay, what does this have to do with anything? What could this possibly have to do with a real-life problem, like, say, figuring out how long it'll take to save up for a new stereo? It seems totally unrelated, I get it, but the connection between them, that's the key to understanding everything.
And this right here is where it all begins. This picture of a balanced scale is our starting point. It's a really simple but powerful idea. Whatever's on the left side is perfectly exactly equal to what's on the right. If you can just hold on to that one idea of balance, you're already halfway to understanding algebra.
And that leads us perfectly into our first big idea, the balanced scale. You can think of this as the absolute #1 non-negotiable golden rule of algebra. Once this clicks, everything else just falls into place.
So let's break that down. What is an equation, really? Well, it's just a fancy way of saying this side equals that side. That's it. It's a statement that promises things are in perfect balance. Just like an old-fashioned scale, an equation tells us the weight on both sides is exactly the same.
And this is it. This is the single most important rule we'll talk about today. To keep that scale from tipping, if you decide to add, say, a 10-pound weight to the left side, you have to add a 10-pound weight to the right side too. If you take away half the stuff on one side, you have to do the exact same thing to the other. That is the golden rule. It's our guide for literally everything that comes next.
Okay, so we've got our golden rule locked in. Now let's put it to work. We're moving on to our next section, which I like to call the mission to isolate. Our whole goal here is to figure out the value of that mystery number x by getting it all by itself.
All right, here's our first challenge. 7 plus 4x equals -13. As you can see, our x is kind of buried in there with some other numbers. Our job is to carefully unwrap it using that golden rule.
So how do we do that? Well, we kind of work backwards to undo what's being done to x. First, let's get that 4x part all by itself. To get rid of that positive 7, we'll subtract 7. But, and here's the rule, we have to do it to both sides to keep things balanced. That leaves us with 4x equals -20. Now we're so close. To get x alone, we just have to undo the multiplication, so we divide both sides by 4. And boom, there you have it, x equals -5. See? By making sure we kept the scale balanced with every single move, we figured out the one number in the universe that makes that original statement true. Not so bad, right?
Okay, you ready to level up? We're going to talk about something that makes a lot of people nervous. Fractions. But here's the thing. They follow the exact same rules we just learned. The whole trick is to not let them intimidate you, because we have a strategy.
Now let's look at a super common trap that's really easy to fall into. Someone might see this problem and think, oh, x is being divided by 5. I'll just multiply by 5 to get rid of it. It seems logical, but it's the wrong first move, and it throws the whole scale out of balance.
So here's the right way to think about it. Remember our mission? It's always to isolate the term that has the x in it. In this case, that whole term is x divided by 5. So before we even think about that division, we need to get rid of that pesky -4. And we do that by adding 4 to both sides. So once you add 4 to both sides, the equation becomes much simpler. X divided by 5 equals 15. Now you can deal with the fraction. You multiply both sides by 5 and you get the correct answer. X equals 75. The big takeaway here, always, always, always undo any addition or subtraction before you deal with multiplication or division. All right, you're doing great. You ready for what I call a pro move? This next tool is the distributive property. It has a kind of fancy name, but it's really just a fantastic shortcut for dealing with equations that have parentheses.
Take a look at this. All the distributive property means is that the number hanging out on the outside of the parentheses needs to be multiplied by every single thing on the inside. So the 6 multiplies the 2x, which gives us 12x. And then the 6 also has to multiply the 4, which gives us 24. It's like you're delivering a newspaper. You have to make sure you give one to every single house on the block.
Okay, let's try it out on this problem. 11 equals -4 times the quantity z plus 2. First things first, we distribute that -4 to everything inside the parentheses. That gives us 11 equals -4z minus 8. And hey, look at that. Suddenly, it's a simple two-step equation, just like the very first one we solved. We just add 8 to both sides, divide by -4, and we've got our answer.
And now, we've arrived at the big moment. We're going to answer that age-old question that every math student has asked at some point. When am I ever going to use this in real life? Let's see how all these skills come together to solve a practical problem.
So picture this. A teacher, Mr. Maxwell, buys 32 calculators for his class. He gets a $5 discount on each one, and his total bill comes out to $960. The only thing we don't know is the original price of one calculator. This is a perfect job for algebra.
You know, the real trick to any word problem isn't the math itself, it's translating the story from English into the language of algebra. So first, we pick our unknown, x, which will be the original price. The price he actually paid is that original price minus the $5 discount, so x minus 5. And since he bought 32 of them, his total is 32 times that price. And we know that total is 960. And just like that, we've built our equation.
And when we solve that equation, using our distributive property and that golden rule of keeping things balanced, we find our answer. The original price of each calculator was $35. We took a real-world problem, turned it into a puzzle, and used our tools to find the solution.
So there you have it, the golden rule of balance, isolating the variable, tackling fractions, using the distributive property. You now have all the core tools you need. So I'm going to leave you with this final challenge. Take a look at this equation on the screen. Knowing everything you know now, how would you approach it? What would be your first move? The tools are all yours. Go for it.